Now we're going to go over a complicated subject. Even though there's only a few components involved, it's still a little complicated. We'll try to simplify it. Now, when you have certain accessories for your seats, your power seats means one thing should come to your mind. Power seats means, in this case, it means there is a motor. Now, you could go forward, you could go back, you could go up, you could go down, you can tilt, right? And also you could recline. So and you also have something called a lumbar, actually, for the back support. Anyway, we're dealing with now the left front. The left front is for the driver. Then there's another schematic for the passenger. Anyway, for Toyotas, Hondas, same concept. For most vehicles, you need a switch, you need a motor, you need a fuse, you need 12 volts. Stressing the point, the motor. We do not let's say you go front and you go back. You slide front, you slide back. We do not have two separate motors for each position. We have one common motor, meaning a bidirectional. What do I mean by that? That means if you go, let's say, if I'm going to slide forward, this will be going, this motor, this is the symbol for a motor. M is motor. That means current will be flowing through the motor in one direction. If I want to slide back, what do you think will happen? Take a guess. Well, that motor will now turn in the other direction. Bidirectional. Okay, bidirectional. Meaning two different ways it can rotate. Okay, so it's not two motors, it's one motor doing the task for two motors. All right, we don't want too many components. The more components that you have, the more the manufacturer has to spend money. And when you're making hundreds of thousands of cars, it all adds up. Anyway, for example, what's involved? We always start from 12 volts over here, right? We start from the fusible link over here, which is actually a fuse. So 30 amp fuse, it's a lot. We follow the pink line. Okay, we have switches over here. Depending which you want, the switch will be closed. So let's say I want to go front, I want to slide front, I want to slide rear. Let's say I want to slide to the rear. I want to slide to the back, right? When you want to slide to the back, this one over here, instead of being in the position G to I, it'll be G to H, and I designated each one so you would know which one I'm referring to. So far, we're still following this pink line, always, and this is the switch, all the switches. We're going the pink line into pin 8, the white wire. We're going now, which way are we going? We said we're making contact from H to G. That means the switch. This is the symbol for a switch. The symbol for the switch will be in this position. We follow the pink line. We come out of the motor. We go out here, right? Now, this is at rest. This position is at rest. This is not activated. That means it's still in the position of J, and L. If it's activated, it would be J to M for front. We're not going to the front, we're going to the rear. Therefore, we're activating only this one. This is at rest. This is the normal position for this one. Since this is the normal position, we connected the pink wire going up here. It came out of the motor. Current came out of the motor. Goes at J and says, where do I go now? Current thinks to itself, which way should I go? Well, you know what? This way is open. That's not good for me because I need a complete path to ground. It looks at this path and says, okay, this is closed. I'm going to take this path. Current says, okay, I'll go from J to L. Come out here, the pink line. Now, current says to himself, I need a ground. Somehow I need to get to a ground to complete my path. Always, that's number one criteria, a complete path to ground. I go over here, look at the arrows. I come out here, follow the arrows. I highlighted everything for you. 0 volts, with seat heater. We come over here, and sure enough, we're at ground. Follow it if you can. I'll zoom out so maybe you can understand what I'm talking about. Again, we come over here. We come over here to this point. This point means there's a connection. It's a node, or they call it a splice. Follow the pink. We come over here. Go through this. So you should have 12 volts here. You should have 12 volts here. 12 volts over here. We come out. How much should we have here? Should we have 12 volts? No, we should have 0 volts. Why? Because we're connected to ground. We're connected to ground. Okay? That's when you want to go in the rear. You want to go slide back. Let's say I want to slide forward. Guess what? We just activated this switch from JL to JM. This one is going GI. I mean, how confusing is this? Tell me, huh? When I first looked at this, I said, whoa, this is confusing, but this is how it works. Anyway, one is at rest and one is activated. One is activated, one is at rest. You have to know the correct position of the switch. If you don't know the right position, it'll throw you off completely. That's the hard part of it. But anyway, if I want to go front, I'm activating a switch from this one to this one. So JM. Okay? Now, what are we going to follow? Which way are you going to follow? We're going to come over here. Notice one thing. This fuse is for rear, for front, for both. We come over here. Instead of going this way, we can go this way. Why not? Because the switch is in this position. We need a complete path to the motor to ground. We can't go here. It's open. What about the other path? What about this path? This path. Can we go this path? Yes, we can. Why? Because the switch now makes contact from J to M. So now the switch goes here, here. Follow the green arrows. I didn't want to overlap on the pink, so I just put the arrows, the green arrows. So going from here into pin 2, this is pin 1, into pin 2, and also into the motor. That's why I wrote over here, how much should you have volts? 12 volts. How much should I have on the other side? 0, when this is in this position. See, this is the confusing part. When we're doing in one position, this will be 12 volts here, 0 volts on the other side. When we do the other position, when we want to go front, we want to slide front, this is now vice versa. This is 12 volts, this is 0 volts. This is why I write the voltages for people to understand. No other channel will you find somebody taking time to put the voltage measurements out of all the schematics. Nowhere will you find it. Nowhere. But it makes it easier. Hey, as long as the viewers are happy, even though I don't have views, but anyway, hey, I have them. At least I have the minutes. So this comes in here. So we're going, follow the green, going into the motor. We go out the motor. If we go in the motor, we have to go out the motor. There's no other path. Out here, now the current is thinking to itself, which path should I take? Can I go from G to H? No, you can't. It's open. Can I go from G to I? Yes, it is, because the switch was not activated for rear. It was just activated for front. So we go here, 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 right? We go over here. We go back to, again, the same place. Boom, to ground. So guess what? This path is common for front going and for rear. Okay? Let's look at that one again. Here, 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 here. Right? We come over here. The switch is now in this position. Switch in this position, follow the green. Follow the green. See the green? Follow the green. The green, the green, the green. Follow now the pink, obviously. And guess what? Guess where it's taking us? We come over here. We come over here. Come here, actually. I'm sorry. We come over here. I'm sorry. We come over here. Out here. Into this. And this is the ground that's shared by both. See how confusing it is? Wow. Anyway, now, let's take, that's for that one. I'm not going to go over every single one of them because basically it's the same concept. Motor goes in one direction, goes in the other direction. If I want to tilt up, it'll go in one direction. I want to tilt down, and it'll go the reverse direction. Now, simple troubleshooting. You don't know anything about the circuit. You don't understand schematic. You don't understand motors. You just know there's a motor, there's a switch, there's a fuse. If I cannot go up, or let's say I cannot go forward, I cannot go back, can the motor be the problem? Yes, it can. Can the fuse be the problem? Yes, it can. Can the ground be the problem? Yes, it can. Why? Because it's common to both. Okay? Can the switch be the problem? It can, but usually if the switch is bad, you'll have it in one position. Why? Let's take another case. Let's say I can only go forward, I can't go back. Is the motor good? Yes, it has to be good. Why? Because if the motor would be bad, it wouldn't be turning even in one direction. Whether it turns, whether it lets me go forward, whether it lets me go rear, is not a concern. It's moving. It's controlling the power seats. It's controlling the seats, even though it's only going in one direction. So the motor is doing its job. But you could ask me, yeah, but it's not going front and it's not going rear. That has nothing to do with the motor. What about the switch? Can the switch be in the wrong position? Yes, it can. Absolutely can be in the wrong position. Can the fuse be bad? No. Why do I say no? Because if the fuse be bad, what do we say? It controls both. If the fuse be bad, then it wouldn't be able to go front and to the rear. Right? Well, how about the ground? Would the ground be bad? Look at the ground. No, it can't be the ground. Why? Because if the ground be bad, we wouldn't be able to go front and rear, or up and down. Two positions. The fact that we can only go in one position tells us at least the motor is working. It tells us at least that the fuse is working. It tells us at least the grounds are good. If we knock out the grounds, nothing will work. We knock out the fuse, nothing will work. If we knock out the motor, nothing will work. The only thing left is the switch. Inside over here, the switch, the seat switch is over here. And you do it by measuring 12 volts. I put the meter over here, the motor. If I don't get 12 volts going with the switch back and forth, right? It could be the switch, but also it could be a wire. But also, if I don't get 12 volts over here, something is wrong with the switches or the fuse. If I get 12 volts in either position, right, and the motor is turning, I know I have 12 volts in the motor. Anyway, please go to my channel, Joe Electronic Schematic for Auto. My other one, Automotive Electronic Schematics for Joseph.